Unity, Godot, Unreal, or any other game engine or framework. It doesn't matter what you pick. If you want to make games, you need to know and choose how to process game time. Picking a wrong one will make your game fail to run properly in all players' devices or give a bad gaming experience. What are the solutions and how can we achieve a good game performance in all devices? Let's discuss this after the intro. Welcome back. If you are new to the channel, I make games, and you can download many of my games from the link in the description below. Player input, physics, movement and animations, network communications and much more. All of these need to work together and be in sync in time. To make them work together, time is the main point we want to talk today. How to orchestrate time in a way that will work in your games. Let's go to the basics, so we can design a very simple solution. First, a player will see your game in a monitor. The refresh rate in which it displays a single image is measured in Hz, so a 60 Hz monitor will refresh the screen 60 times per second. A 50 Hz monitor will refresh 50 times per second. There are faster monitors that can display 100 Hz, 144 Hz, and much more. The more refreshes per second, the smoother the movement, as long as the game supports that. But as a developer, you need to make sure that no matter how many refreshes are there, your game should work at a constant speed, so it will not run faster if your monitor is faster. You can define in your game engine how do you want to deal with time by setting your game to fixed time step or variable time step. So if your player is using a 60 Hz monitor, your game will update 60 times per second if it is in sync with the monitor. Your delta time or time passed between drawings will be fixed to 1/60th of a second. If your game is able to finish each loop before 1/60th of a second, your game will run smoothly all the time. This is the ideal scenario where physics, input and everything else works perfectly. This can be your scenario in your game development machine, but in a player's computer it may not be the case. What will happen if your game is not in sync with the monitor? Let's say your game can generate 30 frames per second or FPS. What if your game processes 25, 35, 50, 80 FPS at different times depending on the load? So welcome now to variable time step. You can pass the adjusted time to your game logic. It will work but will introduce several issues. For example, if you are using physics calculation, the time passed since the last update may be too large. So in those cases, the output will be wrong. So using directly the delta time or time pass will create more problems than solving them. What if your game becomes so slow that you give an update every second or 10 seconds? So in those cases, it will be better to use a semi-fixed time step. What this means is that if the delta time is greater than a value you define, you can actually make updates in your game at a 1/60th of a second until the total time equals the delta time. So if your delta time is 1 second, you run your game physics and updates 60 times if you want a 1/60th of a second update. That way, you ensure that all the updates expected will happen. What if you have an additional time that do not fit into 1/60th of a second? You can keep it for the next update cycle, so it is not lost. This sounds nice on paper, but there is a catch. If you do 60 updates in just one time, most probably your game will need even more time to process the next frame, so your game will be trapped into an infinite number of updates, because there is so much to process that it lags behind even further with each new update and become unresponsive over time. This is the spiral of death. To prevent this, you can limit how much time you can keep, so after that limit, every additional time step is discarded, so your game will run slower for some time until it catch up. Even though this is not perfect, it is much better than crashing the game. One better approach is to divide and conquer and use different time steps for the things that can run in parallel, like a different time step for physics, network, multiplayer, movement, input, and anything else, so each one will manage their own time. So usually a game engine will give you only one delta time, but nothing stops you from creating additional variables that can keep track of the time passed, so each module can get their own updates at the time you want. I hope this can give you some ideas on how to handle time in your games. Let me know in the comments below. If you want to support my work, please click like and subscribe, and click on the notification bell so you do not miss my next update. Thank you so much for watching my journey. See you next week.